Hi everyone, welcome to this video where, as I told you earlier, we will be discussing some of the practice problems of Banker's algorithm. I have brought some numerical examples so that we can understand both the implementation of safety algorithm as well as the resource request algorithm also. So this is the first question. You can see this, consider the following snapshot of the system. I am given 1, 2, 3, 4, 5 processes. The max is given, which is the maximum number of resources that P0 or P1, each one of these processes require for completing their execution. And then I have the allocation, which is the current allocation, and then the available number of resources. So the first question here is, using Banker's algorithm, answer the following questions. It is asking me how many resources of type A, B, C, D are there. For that, what I need to do is, I need to calculate first A. So the resource category A, I need to check what is the current allocation of A. 4 plus 1, 5, 5 plus 1, 6. Let me write it down. So 4 plus 1 plus 1 plus what is the available? 3. So which gives me 5, 6 and 3, 9. So there are total 9 instances of resource category A. Similarly, let me calculate for B. So B, 1 plus 2 plus 6 plus 2 plus 2, which gives me 3, 9, 11, 13. And then let us calculate the number of instances of category C. So for C, 5 plus 3 plus 1 plus 1. So 8 plus 2, 10. And for D, which is the last category, 1 plus 4 plus 3 plus 2 plus 1, which is equal to 11. 5 plus 3, 8, 10, 11. So the reason why I made this calculation is because these are the instances of resource categories which are already allocated, and plus this is the remaining. The question is how many total resources of each type are there. So for me to calculate this value, I need to find out how many of them are allocated plus how many are available. So once you add all these things up, you get the total number of resources. So 9, 13, 10, 11. So this is the first question. The second question is, what are the contents of need matrix? So as you know already, need matrix means you need to find the difference between the maximum requirement and the current allocation. So if P0 says that it requires maximum of 6 instances of resource type A for it to complete execution, and it is currently allocated 4 instances, the need of P0 of category A will be 6 minus 4, 2. In this manner, if you calculate, so 2 and 0 minus 0, 0 and 1 minus 0, 1 and 2 minus 1, 1. Similarly for P1, 1, 6, 5, 0. 1, 6, 5, 0. P2, 1, 3 minus 2, 1, 0, 2. So for P2, 1, 1, 0, 2. Similarly for P3, if you calculate 1, 0, 2, 0. 1, 0, 2, 0. P4, if you calculate 1, 4, 4, 4. This is the need matrix. If you remember correctly, you always calculate need as allocation. Oh, sorry, let me put it this way. We need to calculate the need matrix as this manner. Need is equal to max minus allocation. Okay, so this is the formula wherever you need to calculate the contents of need. So let me proceed on. So I gave the answers for these two, 9, 13, 10, 11 of each resource category. These are the 4 resource categories that are there, and these are the number of resources of each category. And then we calculate the need matrix also. The next question is, find if the system is in a safe state. If it is, find the safe sequence. Now for that, we have to employ the safety algorithm. And for ease of usage, I'm copying it down here. My suggestion to you guys is also that if you are doing bankers algorithm, problems on bankers algorithm, it is always better that if you write these things down so that you don't make any mistakes. Okay, so this is given, this is given, this is the need matrix we just calculated. Okay, this is the need matrix. So let's start our safety algorithm. Now in safety algorithm, the first thing you do is step 1, work is equal to available. So here available is nothing but 3, 2, 1, 1. So my work is 3, 2, 1 and 1. Now let me start with from I is equal to 0. Initially I am assuming that all the processes are false, that the finish of all these processes is false. From that, first for I is equal to 0, that means for process P0, P0's need is 2011 here. So for this P0 2011, I have to check whether it is less than the work or not. Yes, it is less than work. So 3211. So P0 will be added into the sequence first. I'm writing down the sequence here. So first P0 goes, and now my work will become work is equal to 3211 plus what is the allocation of P0? 40001. So 4001, which is equal to 7212. So P0 is done. Let's check for I is equal to 1. Let's check for I is equal to 1. For I is equal to 1, the need is 1650, which is less than, which is 1650, which is greater than your current work, which is 7212. So I cannot add I is equal to 1 right now. I have to move further. I have to check for the next I, which is I is equal to 2, which is nothing but for P2. What is the need of P2? 1102. So 1102, when you compare it with 7212, it is less than 721 and 2. So in the next sequence, the next process in the safe sequence is P2. Now what will be my work? Work is equal to, so work plus allocation. So what is the current work here? 7212, 7212 plus what is the allocation of P2? 1254, 1254. What will be my new work? 8466. This is my new work. So I2 is all, that means P2 is also completed. Okay, P2 is also done. Next I have to check for I is equal to 3. So what is I is equal to 3? What is the need for P3? 1020, which is less than 8466. So my new work will be current work, which is 8466. So here I have to add P3, 8466 plus what is P3's allocation? 0633, 0633, which is equal to 8, 10, 9 and 9. Okay, and then after I is equal to 3, this is also done. I move towards I is equal to 4. So this is now here I make it as true. This I make it still as false. This I make it as true. And this I make it as true. Right. This means that I'm adding it into the safe sequence. That's all. Next comes I is equal to 4. What is I is equal to 4's requirement or the need? 1, 4, 4, 4, which is less than your current work, which is 8, 10, 9 and 9. So I is equal to 4 also. That means P4 will be added next to the safe sequence. So now the work will be 8, 10, 9, 9 plus what is the allocation provided to P4? 0, 2, 1, 2. So now the work will be 8, 12, 10 and 11. So finally after this there is only one I left, which is I is equal to 1. I'll go back and I'll check for I is equal to 1 now. So for now I is equal to 1. What is the requirement? What is the need? 1, 6, 5, 0, which is less than the current work 8, 12, 10, 11. So I is equal to 1 will also be added. That means that now the work will become work is equal to 8, 12, 10, 11 plus the allocation of P1 1, 1, 0, 0. So after completion of all the process, I should get my original resources back. 9, 13, 10, 11, which is the value which you calculated for A, B, C, D for each of the resource category. So now, because I could find a safe sequence of P0, comma, P2, comma, P3, comma, P4, comma, P1, I can say that this system is in a safe state. So this is in a safe state and this is your safe sequence. Okay, this is how you need to work using the safety algorithm. Let us try another example. Okay, so this is another example. Assume that there are 3 resources A, B, and C. There are 4 processes P0, P1, P2, P3. At T0, we have the following snapshot of a system. Okay, fine. So generate the need matrix. Once again, need matrix is nothing but max minus allocation. So for P0, let us calculate 2 minus 1, 1, 1 minus 0, 1, 1 minus 1, 0. So you get 1, 1, 0. Similarly for P1, 3, 3, and 4 minus 2 gives me 2. For P2, 3 minus 3, 0, 1, and 1. And for P3, 1 minus 1 is 0, 1 minus 0, 1, and 1 minus 1 is 0 again. So this is the need matrix which is written. Now it is asked me find out if the system is safe. Once again, let's work with our algorithmic approach. First, what I need to do is work is equal to available, which is 2, 1, 1. Now let me start with I is equal to 0. I is equal to 0's need is 1, 1, 1, 1, 0. So because it is still 1, 1, 0 is less than 2, 1, 1, I0 will be added to the safe sequence. I'm writing down the sequence here. First comes P0. So now the work will be 2, 1, 1 plus what is the allocation of P0? 1, 0, 1. 1, 0, 1, which equals 3, 1, 2. Let me check for I is equal to 1. Here the need is 332, which is greater than 312. So I1 cannot be added. Let me move on to I is equal to 2. I is equal to 2 means P2, 0, 1, 1, which is less than my work, which is 3, 1, 2. So now the new work will be work is equal to 3, 1, 2 plus allocation of P2 300, 300, which now I will get as 612. This is the new work, and after P0, P2 can execute. I need to add this into the safe sequence. Next, let me try for I is equal to 3. So here the need is 0, 1, 0, which is less than your 612. So now the new work will be after it releases all the resources 612 plus the allocation of P3 101, that is equal to 713. So next comes P3. The only I that is left over here is I is equal to 0, which equals where I is equal to 0, I is equal to 1, my mistake. I is equal to 1, whose need is 332, which is still greater than 713, because this doesn't, I don't have sufficient resources of category B. So I cannot grant this request, and there is no safe sequence here because P1's request cannot be granted. P1's request cannot be satisfied. Request cannot be satisfied. So I say that this system is currently in a unsafe state. Unsafe state simply because I cannot find a safe sequence. Safe sequence has to be one where I should be able to satisfy or successfully satisfy each one of the process request in any order. Doesn't matter, doesn't need to be in one particular order. In any order, if I'm able to satisfy the requests of process, then I can say that there is a safe sequence. But here in this example, I cannot find a safe sequence, since I said that this system is in a unsafe state. Okay, so let me move on to another example. So once again, it is given there are 3 resource types, and I am having the 3 process and 3 resource types. The 3 processes are P0, P1, and P2, and the 3 resource types are R0, R1, and R2. Okay. Now it is directly asking me show the system is in a safe state, and then please calculate to see that if a request by P0 for 1 unit of resource type R1, can this be granted? Now here for this case, I need to run down the safety algorithm. And for this case, I have to run the resource request algorithm. Okay, resource request algorithm. First, I need to find out the need matrix. So let me calculate the need matrix. From this point onwards, I can start my calculations. So what is the need matrix? Just calculate max minus allocation. So this will be 3, 1, 0. And then what I need to do is after 3, 1, 0, P1 I will get is 1, 2, 0. And after that, I will get P2 is 0, 2, and 1. So this is the need matrix. First, let me check if I can do the what is the work. Let me verify whether it is in a safe state or not. It is asking me to show it is in a safe state. So it should be in a safe state. Work is equal to 2, 2, 0. First, let me start with I is equal to 0. It doesn't satisfy because 310 is greater than work. So I is equal to 0 will not be taken first. Next, let me start with I is equal to 1. I is equal to 1, 1, 2, 0 is less than 2, 2, 0. So now, which makes my work is equal to 2, 2, 0 plus 0, 3, 1. Okay, which makes it 2, 5, 1. Next, let me look at that. I is equal to 2. So the safe sequence here will be first P1, comma, for I is equal to 2. The need is 0, 2, 1. 0, 2, 1 is less than 2, 5, 1. So now I have to update my work. Work is equal to 2, 5, 1 plus what is the allocation? 102. 102, which gives me 3, 5, 3. And finally, let me try the I is equal to 0 again. For I is equal to 0, the requirement is 3, 1, 0 now, which is less than the work 3, 5, 3. So after P1, I will go for P2, and after P2, I have P0. There is a safe sequence here. So I can say that this system is in a safe state because a safe sequence exists. So this is a safety algorithm, that's okay. Now I say that this is in a safe state because there exists a safe sequence. This is my safe sequence. What about the next question? If a request by P0 for 1 unit of resource type R1, that means request, let me write down here, just draw a line. So I have to invoke the resource request algorithm. So for that, what I need to do, I need to first check the request of 0, which indicates this request is being made by P0, 1 resource type of R1. That means it will be 0, 1, 0. For this to be, at least to proceed further, first I need to check 2 things: whether this request is satisfying 2 things or not. So if this request is 010 is less than the need or not. The need for P0 is 310, right? So step 1 is proved. After that, 010 is less than available or not. What is available? 220. 220. So this is also true. Both step 1 and step 2 are okay. Then we need to go for step 3. In step 3, you have to make necessary changes, right? So now what is the new available? So what is the new available? I have previously 220, out of which I am granting 010. So my new available will be how much? 210. Next, what is now the allocation for? What is the new allocation for? Allocation of P0. What is the allocation? It is 102 earlier. Now if I add this 010, it will become 112. Finally, what is the need? Need of 0 will be, earlier it is 310. Now you have to minus or subtract the resources that are allocated 010. So it becomes 300. Okay. Now using these three things, you can rebuild this particular state. So now if I have to run the safety algorithm, for me to run the safety algorithm, the need matrix will be, so here the need matrix will be, I'm just writing it down, the need matrix for the process. There's not much big difference except for the fact that for P0 it will be 300, and for the one it will be 120, and for this one 021. Now the work will be the new available, which is 210. Now I have to start looking at from I is equal to 0. So for I is equal to 0, the need is 300, which is greater than work 210. So I0 cannot be cannot be added. Next, I is equal to 1. The need is 120. Once again, this is greater than 210, simply because I don't have the enough resources for B category. So I is equal to 1 cannot be added. Next comes I is equal to 2. The need for I is equal to 2 is 0, 2, 1, which is once again greater than 210, simply because I don't have the category C resource. So with this work of 210, I cannot satisfy any of the requests. I cannot satisfy any of the requests. So simply put, this request cannot be granted. This request cannot be granted. Simply because if I grant this request, the system is going into an unsafe state. If it goes into an unsafe state, there is nothing that we can do. So this request cannot be granted. So these are the three problems which I thought of, which might help you to understand Banker's algorithm better and to take up the numerical problems of Banker's algorithm with much more confidence. So hopefully you understood this, and please do prepare yourself. You make a habit of taking 1 or 2 other problems from the textbook also. You can solve them. You can get used with the different types of problems that are asked on Banker's algorithm through GATE questions also. So thank you very much for watching, and good luck.